Hello, everyone. Thank you for joining us. This is Dr. Joseph Burrascano. I'll be speaking tonight on behalf of IGeneX. We'll be joined later on by Dr. Shah during the question and answer period. And what I want to talk to you tonight about is reflex testing for borreliosis. This is an outline. We're going to go through this pretty quickly. First of all, I want to give you an overview of the Borrelia. And notice it's not just Lyme disease, it's more than Lyme. There are a lot of different Borrelia affecting us and our patients in North America. So I want to go over them in some detail. And along the same lines, the testing for these have to be understood. I want to go over the limitations of the FDA test kit serologies that a lot of people are using, the pitfalls of the CDC criteria, there are many. And then we'll go through what we call reflex testing. What that means is, how do you manage seronegativity? How do you manage borderline results? We're going to talk about that for Lyme disease and for the other Lyme Borrelia, for tick-borne relapsing fever and those Borrelia. And obviously go over the importance of testing for all of them when you have a patient with Lyme disease. Finally, we'll go over the recommended testing to do and a word about test panels, which are very helpful. So borreliosis, I mean, we know it's prevalent. We know it's very serious. It can become a potentially chronic and debilitating illness. It can affect central, peripheral nervous system, the joints, heart, GI tract, cognition, mood, affect pretty much the whole entire body, as you know. It also can impair immunity, lead to opportunistic infections, worsen the co-infections, and even lead to an auto-inflammatory state that mimics autoimmunity. It's also known that chronic forms of Lyme can impair the detoxification pathways. And it's not uncommon for Lyme patients who are chronic have a buildup of mycotoxins, heavy metals, pesticides, herbicides, and more in their system. And all of this, of course, can have a very negative effect on relationships, family, friends, work, school, even among your healthcare providers. They start to label you as being a little bit off. So obviously, with all this trouble, we need to come up with a way of making a firm diagnosis and with a good laboratory support behind us. So we'll start by saying, we know that Lyme testing has been really insensitive, and we've seen many cases who've had negative Lyme testing. We call this seronegative Lyme disease. In fact, if you look at publications and you average them out, there's about a 50% pickup rate of real Lyme disease based on these test results. You should have better than a coin toss when we're diagnosing our patients. So what is this reflex testing? It refers to how do you handle a borderline and its seronegative result in a patient who you're convinced has at least a good chance of a tick-borne disease. We know that seronegativity is prevalent, and a negative test does not rule out infection. I mean, we all know that, but I can't tell how many times I've had calls from people saying, oh, we know that Lyme has been ruled out because the test was negative. I kind of laugh to myself because sometimes I just have to let it go. Sometimes I start a fight, but that's a different story. So we'll talk about, why does seronegativity happen? What does it represent? Because it may not be what you think. Go to review which tests we should be doing when the basic or screening tests are negative, and provide an understanding of what the newer testing technology offers and when to do what. Now, we're going to go through this because I find it interesting. Why have Lyme tests been so insensitive in the past? Well, there's some usual obvious reasons, okay? First of all, serologies have to accept a trade-off between sensitivity and specificity. Sensitivity means, can someone have Lyme despite a negative test? Well, we know that impaired immunity can occur in advanced cases of Lyme, so the serum antibody levels may be too low to be detected, especially by the FDA type of test kits that are so out there. Also, we know that immune complexes can form, and these trap antibody, potentially causing the free antibody levels to be too low to be detected by these tests. Then the issue is specificity. How sure are you that a positive result is really truly positive? Well, we know that because non-Lyme Borrelia or non-Borrelia antibodies may be detected by these FDA types of test kits, sensitivity cannot be tuned up to overcome the limitations. Again, it's a trade-off, sensitivity, specificity. And because of cross-reactivity on these old-fashioned serologies, you have to turn down the sensitivity to not have too many false positives. So there's some not so obvious reasons. Number one is there are many more Lyme Borrelia out there infecting our patients. For example, we know about standard so-called laboratory Lyme, Borrelia burgdorferi stricto, that's usually strain B31 in most labs. It's tick-derived, and 297, which is a human strain. But in North America, we also have Borrelia, Guarini, Mayonii, Californiensis, Spielmanii, Borreliosis, maybe even more. People travel, their pets travel with them. Birds transport these exotic tick species, so it's not so surprising that all these things are here. Now, the other not so obvious reason is that a whole other group of Borrelia, not Lyme Borrelia, are causing a significant number of Lyme-like illnesses that are also not being picked up by conventional Lyme tests. And that's the tick-borne relapsing fevers. And we know, for example, there's Hermsii, Miyamotoi, what's called Trissica-like. Used to call it Trissica, but now they're not so sure if that's one species or two, so they're calling it Trissica-like. There's Turicate, Texacensis, Coriaceae, maybe even others. But the big news is that tick-borne relapsing fever can present as a Lyme-like illness. And in fact, it seems that the classic so-called textbook picture of relapsing fever may actually be uncommon. I'll show you some reports on that. So yes, tick-borne relapsing fevers, these species are being found in our North American patients. Here's a published report from 2020. 90 patients who met the clinical case definition for chronic Lyme disease, not at all suspected to have tick-borne relapsing fever. 46 were positive for Lyme Borrelia, but there's a whole group of them. There's Californiensis, Spilmanii, Afzelii, Guerinii, and plus some other species that were Borrelia burgdorferi sensolato that they couldn't precisely identify. But the other thing is 56 of the 90, more than half, had tick-borne relapsing fever. And again, the list, Hermsii, Miyamotoi, Trissica, Turicate, and some other species also. 8 were positive for both. So now, we're talking about co-infections of Lyme with, say, Babesia bartonella. Well, here's a co-infection of Lyme and tick-borne relapsing fever. In other cases, we've seen co-infections of several types of Lyme Borrelia, several types of tick-borne relapsing fever, all in the same patient. So let's start with the Lyme disease. As I said, multiple species are present and they're being missed. And I'll give you some clinical series to back that up. Here's a case, 36 patients who are seronegative, single client office. They were tested by the IGeneX IMMUNOBLOT, and they found Mayonii, Spilmanii, Californiensis, Guerinii, Afzelii, Valesiana, and only one B31 burgdorferi stricto. 5 more cases were there they couldn't exactly identify. So here we have seronegative patients. One was a true positive for classic, Borrelia burgdorferi stricto, but all the rest were these other Lyme species that we know are here in North America. It's been published, but the patients were seronegative on a standard Lyme test because these Lyme tests were not engineered or validated to pick up these other species. Now, all these people were North American, United States citizens. 15 of these 36 traveled, but the rest of them did not. So we need to do something better. Now, here's another patient series, 39 client samples. There's Spilmanii, Californiensis, Afzelii, Mayonii, strain B31. They also were 4 cases where the IMMUNOBLOT identified European Lyme Borrelia that were not able to be speciated, and 11 where the sensolato were found that couldn't be speciated. So again, if standard FDA test kit serologies were performed as a sole serologic test, likely only the 2 B31 cases and maybe some of the other ones would have been identified. The rest of the 39 would be incorrectly classified as being seronegative, in other words, false negatives. So again, the person who says to you, or the other physician says, oh, we ruled out Lyme, the test was negative. That doesn't hold water at all. Third series, not to get too repetitious, 11 of them. Of the 11, there were Spilmanii, Californiensis, Mayonii, so forth and so on. But the reason why, if you add these up, they seem to have picked up more than 11. Well, it's because of co-infections I mentioned before. So again, standard serologies were done. Not only would you probably miss many, if not most of these, you would never know that there's more than one species. And why is that important? Well, first of all, the higher the spirochete load, the worse the illness. That's basic science. Second thing is, we don't really know how these 2 different species will interact in a patient. Maybe this is why some of the Lyme patients are really so much sicker. And we all know that the seronegative patients are generally the ones who are more sick. And maybe they have these other species which are pretty bad. So let's go talk about that. What are these other Lyme Borrelia? Well, Borrelia Valesiana actually is closest to Afzelii. It's mainly found in Europe and the Far East, but as you know now, it's also found here. It resists complement-mediated killing like Lyme Borrelia do, but by a novel mechanism. So this has evolved beyond standard Lyme Borrelia burgdorferi stricto. It's also been detected in human spinal fluid in a patient with spastic paraparesis. So this is clearly a pathogen we need to be aware of. Californiensis is closest to Borrelia americana and Andersoni. It's been found in Ixodes pacificus ticks. It's known to be in the California kangaroo rat. It's also found in Brazil. So here we have a North and South American species. Again, probably the birds taking them back and forth. How about Mayonii? Interesting. It's closest to the European species Valesiana, which we just mentioned, and Bissetii, another European species. It's been found in blood and spinal fluid. It's known to be in white-footed mice and red squirrels. Scapularis ticks in upper Midwest, which is not so surprising because a lot of people in the upper Midwest have European heritage. This also resists complement-mediated killing. Interestingly, in Mayonii, there are higher levels of spirochetemia. And what I found most interesting is that people with this don't get an EM rash, they get what can be a macular rash. So if you have someone coming with a multi-system flu-like illness with a macular rash, how many of you would think that this is Lyme disease or a variant of Lyme disease? I know I would not. So now this is kind of news. It's also known to cause nausea and vomiting, which is, again, not something to think about with Lyme Borrelia, and early neurologic involvement, which is not surprising since it's related to Burrascano, which, as I mentioned, has been known to affect the central nervous system. Spilmanii was previously only thought to be found in North America, in European ticks in patients. They found them in the ticks, mice, and rats. This one can cause an EM rash, and it was proven by biopsies. This one, interestingly, they found it has 3 new types of OSP-C and a unique OSP-A. Now think about that. This would either not be picked up at all by standard American testing, even Western blots, or if there were, you'd probably have some atypical bands or very weak bands and would confuse us all. Also, this has 12 plasmids, and the more the plasmids in number, increased pathogenicity and variability because these Borrelia change over time. So let's go through the tick-borne relapsing fever. Now, it's being confused with Lyme disease, and as I mentioned, the classical description can be misleading. So let's talk about classic TBRF. If you went to a textbook or Wikipedia, this is what you'd find. In quotes, recurring febrile episodes that last about 3 days and are separated by an afebrile period of about a week. Each febrile episode involves a crisis. During the chill phase of the crisis, patients develop very high fever up to 106.7, may become delirious, agitated, tachycardic, and tachypneic. Duration is 10 to 30 minutes. This phase is followed by a flush phase characterized by drenching sweats and a rapid decrease in body temperature. During the flush phase, patients may become transiently hypotensive. Overall, patients who are not treated will experience several episodes of fever before the illness resolves. Okay, so that's the textbook. In fact, what's not mentioned here is that during the flush phase, when there's a decrease in blood pressure, there have been patients who had cardiac arrest, even more so during Herxheimer reactions, where this flush phase can be more severe. So this is a very dramatic presentation. You're not going to confuse this with classic Lyme disease. But on the other hand, the same thing goes in reverse. Tick-borne relapsing fever may actually present like Lyme disease. So here's a case of 543 patients, all had suspicion of Lyme disease. None was suspected of having tick-borne relapsing fever because they had a Lyme-like illness. But 29% were positive for antibodies to tick-borne relapsing fever. Now in this series, only 2 species of TBRF were tested for, Termsia and Mayonii. So maybe there was more there. In the California cohort, even 38% were positive for relapsing fever. And again, these are patients who were thought to have Lyme disease. Could this have been seronegative Lyme? Oh, sure, because Lyme tests were never engineered to pick up tick-borne relapsing fever. Now, do we need to worry about it? Well, here's a study published in 2018, and they found relapsing fever Borrelia in humans and in the ticks, again, in the United States, Miyamotoi, Hermsii, Lone Starii, Parkeri, Tricate. They also mentioned Coriaceae, which is known to exist. It's been talked about for decades. I'm not so sure that they found it in humans, though, at least not yet. Look at the map. You know, again, you think about relapsing fever as being something you find in the Rockies and the Sierras, and certainly more out west than anywhere else. But, you know, California for sure, the upper, the West Coast, the Rockies, but also Texas, the upper Midwest, the central Midwest. Look at Michigan, even Florida, all throughout the Northeast, as far north as Maine. And speaking of north, we have Alaska, and it's been found that the birds that go up there can carry these, and it's been found in the ticks that the birds are carrying, and in Hawaii, and it probably was an imported case. Another thing, we also think of tick-borne relapsing fever as something people who are outdoors will get, because these are ticks, which we'll talk about, that they really live in different environment than the typical Lyme tick. So it's thought that, it's outdoor enthusiasts, and sometimes it's thought of as impoverished persons in primitive conditions, in quotes, because it's very prevalent in Africa, for example. However, this study found the emergence of Borrelia Tricate in metropolitan areas. They did a study in Texas. They found the ticks that carry this in San Antonio, Dallas, Austin, which are the 7th, 9th, and 11th largest cities in the United States, And separately, University of Tennessee found 58% of turkeys tested positive for Miyamoto, which is, another one of the relapsing fevers. Now, I want to talk to you about the tick vector because I find this really, really fascinating and something which the average Lyme person probably is not so aware of. They're called ornithodoros. It's a great name, I like it. First of all, these don't live in the grass like the Lyme ticks do. They live in crevices, which can include wood cracks, leaf litter, caves, rock walls, small and medium-sized animal nests and dens, which is why they can be indoors as well as outdoors. In other words, sometimes people have had mice infestation and they do a clean out and they find, in fact, there's some nests within the walls or in the garage or something. Well, these are places where these ticks will live. So besides campers, hikers, and cave explorers, it can be people who just are indoors. Cabins and homes have been found to be infested. Heat brings them out. So you turn the heat on, put on a wood stove, turn on a campfire, they're going to start to come out. Now, I call this the perfect vector. First of all, believe it or not, this tick can survive for decades. I've been seeing reports that they're living for 10 to 20 years. The other thing is, because of transovarial passage of the pathogens, in other words, they're born infected, it serves as its own reservoir. It doesn't have to feed on a mouse or a deer or another animal to acquire or maintain the infection. It's born with it and keeps its whole lifetime, 10, 20 years. Amazing. Another thing, they're rapid feeders and they attach very briefly. The ticks are said to attach only 5 to 30 minutes. And of course, like other ticks, the bites are painless, often go unnoticed. So now, you heard the classic Lyme story. Well, the person has what seems to be Lyme disease, but they were outdoors for a short time. They came in, immediately did a tick check. They changed their clothing, took a shower, couldn't have been exposed for more than an hour or two, even 3, and yet they came down with something. Well, maybe it wasn't a Lyme, Ixodes Lyme tick. Maybe it was one of these. Only it needs 5 minutes of attachment. But the other thing is, this is a study that was written up in 2014. They found that Borrelia characate, which is one of these relapsing fevers, can occur within seconds of the tick bite. They biopsied the ear of a mouse after they attached the tick, and within 30 seconds of the attachment, they found a positive result. So again, we talk about Lyme disease as controversy. Does a tick have to be attached for a day or half a day or 3 days? It's back and forth. Here, it's in the literature. It's attached for only a few minutes, and within seconds of initial attachment, you've got the transmission. So complete game changer, complete game changer. And another thing, these ticks can feed multiple times. There are stories of people who live in, for example, in Africa, they live in huts where there are rock walls, for example, and the ticks come out at night, will feed on the person, go back in the crevice, and the next night they'll do it again, they'll do it again. So this is really a whole different ballgame than Lyme disease. Now, look at the ticks. They said, well, the ornithodoros is a big fat potato looking thing. I would never mistake that for Lyme tick. Well, look at the Ixodes tick when it's engorged. You'd have to really, really look carefully. And the patients who say, oh, I had the tick on me and it was, one of these Lyme ticks that was engorged. How do you know? Could it have been ornithodoros? Maybe so. All right, so some important facts about relapsing fevers. Maternal fetal passage is recognized, accepted, it's not controversial. It happens. Spontaneous abortion, premature birth, neonatal death. Again, accepted, reported, and no one thinks it's controversial. Another thing we learned, reading literature, louse-borne relapsing fever, a little bit different. They find that it can be transmitted via the mucous membranes. In other words, touching your eye, your mouth, and so forth. Now, years and years ago, I talked to Willie Bergdorfer, and he said to me that he thinks Lyme Borrelia also can be transmitted through mucous membranes. Now, I'm not aware of any studies on that. I don't know if he studied it and just never reported it, but he's warned me about that. So, here's the literature on this in relapsing fever. Now, just like Lyme Borrelia, some species of relapsing fever organisms are immune to complement-mediated killing, which is why they can get systemic and be disseminated. There have been reports that Hermsii can cause the ARDS, adult respiratory distress syndrome. Another report I've seen is that prolonged QT interval has been reported. We all worry about QT intervals in our patients because of medications and some herbs that can affect that. But here we see the infection itself can have an impact on the QT interval. Now, some clinical pearls, again, because this is kind of an exotic, previously known to be exotic illness. But the truth is, from a Lyme point of view, it really is a migratory multi-system illness that waxes and wanes, just like Lyme disease, which is why it can be so confusing. I personally think the acute presentation, the textbook one that I read to you earlier, probably is a minority of cases, just like erythema migrans is not always in Lyme disease. It's in a minority of cases. However, on the other hand, there's some other clinical things that may be helpful to you as clinicians. We know that Lyme has a 4-week recurrent cycle of good days and bad days, waxing and waning. This can happen in relapsing fever, but often it's more brief. It's maybe a 2-week cycle, a shorter cycle. So if you see someone with classic multi-system migratory Lyme-like illness that's waxing and waning every 2 weeks, that might be a clue to look for this family of organisms. Also, with this family, you're most likely to have a low-grade afternoon fever. I've found in clinically, a lot of my Lyme patients, the sicker ones, would have a low-grade fever in the afternoon, 2 or 3 o'clock, when they start to feel this real big energy sag come on. And if you have them take the temperature, then it's low grade, 99, 99.2, even 90, 98.9. I mean, it's more than you'd expect, but not really very high. However, if the patient has this fever and it's above what I see as 99.2 being the most I've seen in a classic Lyme patient, you have to start to think of Tick-Borne relapsing fever. Also, because as I mentioned before, there's a greater incidence of GI upset and abdominal pain. So these are things that we think about with Bartonella, for example, but maybe not. Some of them have a higher spark heat load than the Lyme Borrelia. And with treatment, you might get a much more strong reaction. Unfortunately, there's absolutely no information on potential differences in treatment requirements. It's kind of up to us as clinicians, as we follow these patients, get them more accurate testing and see what's going on. If we find there are differences, there may not be, but if there are, we should start reporting them. All right, so how do we test for all these previously hidden Borrelia? Before I go to that, let's go with a little bit of history about Lyme testing, how it began. And I know because I was there, I'm old enough to know. So Lyme testing began back in the day with low technology, simple things called IFAs, immunofluorescent assays. The original IFAs were found to be inaccurate. There are many false negatives and some false positives. And again, the same trade-off sensitivity and specificity. So then they came up with the ELISA. That's an enzyme-linked immunoassay. It basically is IFA technology that's been automated. It's run by a machine with better standardization and so forth. So they're more consistent, but still prone to false positives and false negatives. And some ELISAs are made from just one antigen. Some are made from sonicated Borrelia. A number of different methods are being used for the ELISA, but they're not really consistent. Now, the CDC and some commercial labs claim the ELISA is totally accurate, but we know this isn't really the case. And they do too. So they started to then go further and they developed Western blotting for Lyme in an effort to increase the accuracy. So let's talk about the Western blot and the CDC. All right, number one, in an effort to improve accuracy, the Western blotting was introduced. It supplemented the quantitative ELISA, where you get a number, with a quantitative method that allows for interpretation by the lab and by the user. In other words, you get a report on the bands that show up. Now, to standardize testing and make it more accurate, the CDC did two things. They, number one, created interpretation criteria for the Western blot, and then went on to insist upon two-tier testing. The thing is that CDC's interpretation criteria for the Western blots were developed for epidemiology and not for clinical diagnosis. And even though that's printed right on there, and never meant for clinical diagnosis, government agencies, insurance companies, academic institutions ignore all this and misapply these criteria. And a lot of you have come upon this. Here's the other thing, number two. Western blots are reported, are interpreted by reporting bands. They reflect an immune response to individual bacterial antigens. So they convened a convention to create interpretation criteria to specify which bands were important and significant and which ones you could ignore. However, there are problems. They included bands which were not specific to Lyme Borrelia. In other words, you can get false positives. They excluded bands that are very specific for Lyme Borrelia that can give rise to false negatives. And they intentionally left out two very important and specific bands, band 31 and 34, to accommodate the then upcoming Lyme vaccine. And I say then upcoming because don't forget, this is way back in the 90s. And since then, this has never been updated. Now, the whole convention was controversial. A number of participants disagreed and one even walked out. And the result of this is the low accuracy that we're seeing today that's never really been addressed. All right, now what about the two-tier testing? First slide on this. Ideally, the diagnostic tests should be both very sensitive and very specific. So the idea behind two-tier testing is to begin with a very, very sensitive screening test, very sensitive that you won't miss any cases. But on the other hand, this is at the cost of maybe some false positives. So then if the screening test is positive, then you follow it with a very specific second test to confirm that true positives are really true positive. All right. Obviously, if the first test is negative, which is very sensitive, if the first is negative, then you call the whole test negative and the second test won't be done. Now, for this to work, the first tier, the first test must be at least 99% sensitive, and the second tier should be as sensitive, but also 95% specific. All right, slide 2 on this. The CDC version of the Lyme 2-tier test is to begin with an ELISA as tier 1 and then use a Western blot as tier 2. Now we know the sensitivity of the standard ELISA that they use is no better than a coin toss on average. Maybe some claim as high as 70%, but it's really far short of this 99% standard that they need. So half of the cases, will they be missed? Maybe so. Would you stand for this in diagnosing any other serious illness? No. So what's going on here? Now, the second tier, because a Western blot's interpreted by those faulty criteria that I mentioned before, that limits sensitivity. So even if there's a positive ELISA, many cases will still be missed because these critical bands that I mentioned were omitted. I'm going to go back for a second. The bottom one, for it to work, the first test be 99% sensitive and the second 95% specific, but also as sensitive. Well, if the second test has to be as sensitive as the first, but more specific, then why do the first test in the first place? And that's why a lot of us, before the IMMUNOBLOTS came out, were using Western blots only and not even doing an ELISA. Unfortunately, because some insurance companies require 2-tier testing because they go by government, then you're forced to do that. But the problem is, if you get a negative ELISA, you're not going to get the Western blot. So it's a problem. So what happens? The denialism we've seen. The patients are told they don't have Lyme. They're given other diagnoses, incorrect diagnoses. They're told to live with their symptoms. Some are told they need psychiatric help. I mean, it's almost to the point of being comical. Insurance companies, obviously we know about this, they start to deny coverage. They require a positive test. And their judgment sometimes is done by someone who's not even a clinician, not even a physician, someone who's never seen the patient, so they have no idea about the clinical background. Now, it gets more sinister than that. There have been cases where medical boards have come after doctors for diagnosing Lyme with a negative test. Sometimes insurance companies have been reported to, or at least rumored to report these doctors because they're very expensive to them. I don't know if that's true or not, but that's been what's been said. Okay, let's talk about laboratory testing and the FDA. What is FDA approval? FDA approval is a licensing procedure. It's not intended to be a sign of test validation, okay? So if something is FDA approved, it means it's able to be licensed. It means the test in question is able to be made into a kit, manufactured into a kit that's sold to other labs to be used, okay? It's not a validation, it's licensing. In contrast, lab validation is performed by CLIA, supported by Medicare. Individual states may also have to certify the testing. Certification is not only initially, but on regular visits, and some are not even announced. So lack of FDA approval does not mean an inferior test, but there's more than this. What are these FDA standards? What are these FDA approved Lyme test kits? The FDA approval is based on comparability to a test standard. Their test standard to get a new test approved is an ELISA based on lab strain B31. Now, we know lab strains of Borrelia who are kept alive in continuous cultures. I'm giving it a name. Over time, the cultured Borrelia, they lose plasmids, they lose pathogenicity, and so they no longer represent what actually is infecting our patients. It's also important to know that strain B31 was derived from a tick, not from a human being, and it came from the East Coast of America. May not be like the Midwestern or Western strains, or certainly not the species that we see. So any new FDA-approved Lyme test kit only has to be as good as the current FDA ELISA. So not only is FDA approval, FDA clearance, whatever word you want to use, not a test of validation of accuracy, it's actually just saying it's as good as an ELISA, which we know is not good. Okay. Lab testing, Tick-Borne Relapsing Fever, also has its limitations. And when you do serologies, it's noticed that Tick-Borne Relapsing Fever Borrelia, they also express the band 41, P41. So this can give you a borderline, maybe even a false positive Lyme ELISA. Some ELISAs, as I mentioned, are based on single antigens, and usually it's P41. So if you have a Western blot and suspected Lyme patient, and all you have is a band 41, think about Tick-Borne Relapsing Fever, because that could be what's happening. Another thing I found, OSP is present in Tick-Borne Relapsing Fever in some of the species. So if you have a Western blot, or borderline ELISA or Western blot that has some bands but not a lot, and you really suspect tick-borne disease, think of Tick-Borne Relapsing Fever because it can give you one of these suspicious readings. Another reason, if you go to a commercial lab to test for relapsing fever, they can only test for Borrelia hermsii, and that's it. You can separately order a test for Borrelia miyamotoi, and that's based on what's called a GLP protein assay. GLP is one protein expressed by this Borrelia. It's like having one band on a Western blot, so that's why this is notoriously insensitive. When you do PCR testing for relapsing fever, you mainly can get them from Miyamoto, but if you look on the literature from the test from these labs, their sensitivity is poor. They show the limit of detection. In other words, how many organisms you have to have before they can pick it up. The limit of detection ranges from 5,000 organisms per milliliter to 125,000 per ml. Just as a comparison, IGeneX, they've been validated that their PCR for tick-borne relapsing fever is between 100 and 500. So it's far, far better than what you get from commercial labs, the big commercial labs. Now, obvious question, can seronegative Lyme be tick-borne relapsing fever? Well, of course. Since it presents clinically as Lyme, but it's missed by standard Lyme tests, the possibility is that seronegativity for Lyme may be due to testing for the wrong species. None of the commercial test kit Lyme IFAs, ELISAs, Western blots, PCRs, or T-cell tests has been validated for all the different Lyme Borrelia or for any of the relapsing fever Borrelia. Likewise, when you do relapsing fever serologic testing, it's only been validated against the 2 species, which you do have to order separately. So the solution to this is, number one, be aware of these problems and start to do the appropriate testing. What is this? Well, obviously, we have a better test. That's called the IMMUNOBLOT. IGeneX developed this, and it's a really important advance because it can detect, and in many cases, identify multiple species of Lyme Borrelia, and they have been getting positive results in many previously seronegative patients. Likewise, their tick-borne relapsing fever IMMUNOBLOT can detect and identify multiple species, far more than the big commercial labs, pick up many missed cases, identify most of them, and be positive in patients who are suspected to have Lyme disease. These in general, the IMMUNOBLOTs in general are more sensitive, more specific, and have a greater positive and negative predictive value than any other serologic method. And as I'll show you in a moment, game-changing sensitivity in early Lyme disease. So the technology is different. It uses recombinant antigens that are specific to multiple individual species. They include a large variety of protein antigens. Because they're recombinant, they're less likely to cross-react with viruses, other Borrelia, non-Borrelia bacteria, and autoantigens. And because they're species specific, there's no cross-reactivity between relapsing fever and Lyme Borrelia on these 2 IMMUNOBLOTs. The technology is different. Unlike a Western blot, the IMMUNOBLOTs deliver precise amounts of antigen, that it's recombinant antigen, very precisely made, to specific locations on the membrane, which is drastically improving the accuracy and the consistency. In the real world, this means it's more sensitive, more specific, and like with Western blots, you can get IgM and IgG. All right, so I talked about recombinant. I'd say that really fast. It's like, what? What is a recombinant antigen? These are lab-created proteins that are identical to those of the pathogen being tested. What happens is you take the DNA sequence of the Lyme bacterium or the relapsing fever bacterium that codes for the protein that you're concerned about, you insert this into another host, like E. coli is often used. So this E. coli will then produce a pure protein antigen that then you can use in the IMMUNOBLOT. Now, a Western blot, and in many cases ELISAs, they take a whole organism that they sonicate and they use all the different protein antigens, and that's why you have things that are confusing and giving you false readings. Here, they're actual exact replicas of what you want to look for. So not only do you have this recombinant antigen, but in IGeneX IMMUNOBLOTs, you have a lot of recombinant antigens. Let's see if my pointer works. Here we go. Look, this is an example of an IMMUNOBLOT done by IGeneX for Lyme. Look at all these. You have like over 20 different recombinant antigens on these strips. So it really increases the accuracy, increases the breadth of coverage. So you get a broad spectrum of sensitivity to different Borrelia, different species. So we'll go over them in specific detail. All right, specificity. A lot of information on here, but I want to talk to you about the Lyme IMMUNOBLOT using both in-house and CDC criteria. I'm going to jump right down to the bottom for now. The specificity, whether you use in-house criteria or CDC criteria, is really very excellent. 97 or more percent, in some cases 100% specific. I want to also call your attention to IgM, whether it's in-house or CDC criteria. The specificity on an IMMUNOBLOT for IgM is 99 to 100%, okay? Very important you think about this, because how many of our Lyme patients have positive IgMs late into the illness? And the powers that be dismiss it. Oh, it's a false positive. You don't get late IgM. We know we get late IgMs. Didn't really know what they represented. However, here you find that this has been validated to show 99 to 100% specificity for Lyme disease, for Lyme Borrelia, with the positive IgM. Okay, this is not just early Lyme, but late Lyme. Let me go to the next slide. We'll go to the sensitivity studies. here, this column, you can see with my arrow, is talking about the two-tier testing, a Lyme ELISA followed by a Western blot, and in this column are the Lyme immunoblots. So these are CDC samples, came from the CDC. They include early acute Lyme, convalescent Lyme. Early acute Lyme is EM. That's how CDC defines early Lyme. Then convalescent, which is at least a month later. The neurological Lyme, that's the CDC calls it, Lyme arthritis. You know, we don't stage it anymore, but CDC apparently does. So standard two-tier testing. Early Lyme, 20% pickup in IgM, nothing in IgG. So even putting the two together, you're not going to get much sensitivity here. So that's why they say don't even waste your time doing a serology with early Lyme disease. However, with the immunoblot, not only was the IgM picking up 2/3 of the cases, IgM responses already there, and other tests were not sensitive enough to pick it up. So already you're starting to see some. So if you say if either one is positive, you have a pickup rate of 93.3% of early Lyme disease. Let me say that again. Early Lyme disease, when someone presents with EM rash, if you do a Lyme immunoblot, 93.3% of the time, it'll be a positive result if it's really Lyme disease. It's totally game changing. There's no other test in the sphere of Lyme disease that has 93% sensitivity in early Lyme. Now, again, go back a slide. The specificity, again, for IgM, 99 to 100%, for IgG, 97 to 99%. So again, we're talking about not false positives. If you get a 93% sensitivity, you get a positive Lyme immunoblot on someone with a rash, that's a significant result. And how many of our patients either have an atypical rash, or they had a rash that went away, or then didn't see the rash, it might be somewhere else, but they're having early symptoms. We finally have a test that can be helpful and confirmatory. Now, another interesting thing, convalescent. Stage 1 convalescent, that's again CDC. Someone comes in with early Lyme EM rash, they do a test in the beginning, and then the convalescent test is a month later. So their pickup was still 2/3 of the IgM, 1/3 of the IgG. If you do one or the other, 80% pickup. So here they talk about how you diagnose Lyme is by seroconversion from a negative test to a positive. Even here, it's only 80% with their own samples and their own testing, as opposed to 100% with the immunoblots. Lyme arthritis, neurologic Lyme. Again, immunoblots had 100% pickup rate. So we're talking about a test that's very, very sensitive, but also very specific. All right, so the summary is information you can't get anywhere else. Other species, very specific, very sensitive in early Lyme, picking up things that you can't get anywhere else. You know, can you find these other Lyme species by Western blot or by ELISA? You can't. This is the place to go. Another important thing, the Lyme immunoblot does not cross-react to tick-borne relapsing fever. And because it's a serology, you're going to get a result pretty quickly. All right, what about the Lyme IGeneX broad coverage assay? What is that? Well, what IGeneX has done is they realize that not everybody wants to go full out for an immunoblot. In some cases, it's a matter of economics. So they developed a total replacement for the IFAs and the ELISAs. It's a single test using recombinant technology that replaces the ELISA of the IFA. It reports IgM and IgG together. So it's a simple yes or no result. It's very easy. Say you do the broad coverage assay, positive, yes, you have it, negative, no, you don't have it. Doesn't identify species. If you want to know species, you need to do the immunoblot to get that information. But this is very cost effective, again, rapid turnover. So it's a very cost effective and logical replacement for an IFA and an ELISA. Now that this test is there, I don't think anyone should be doing ELISAs because we have a much, much better test that's comparable in price. I just want to talk about the PCR. You know, kind of the topic today has been, there are all these different species out there, and you want to make sure that you have a broad coverage to pick them up. Well, the IGeneX PCR, as sensitive as it is very genus specific. In other words, it's the genus Borrelia, not the species. So you can get a positive when you have not just Borrelia sensu stricta. The other thing a lot of people don't understand or realize is that when IGeneX does a PCR, they will run as many as 4 PCRs with every sample. So if you submit whole blood and serum, they can do genomic and plasmid PCRs on the whole blood and genomic and plasmid PCRs on the serum. So that's why the real world sensitivity is 1 to 500 copies per ml, as opposed to the other labs which have thousands, because they're doing 4 PCRs for you. All right, so when do you order PCR? Well, again, it's very early Lyme, before antibodies may be developing. In those who are immunosuppressed, where you may not get a serologic response, and also in the very ill late stage patients where the germ load can be higher. All right, we're going to go back to tick-borne relapsing fever again. This time we're going to talk about immunoblots for the tick-borne relapsing fever organisms. So again, by design, it's better. It uses these recombinant antigens, not just one, but multiple. And because it's able to use these, it can detect a lot of the commonly found species, not just Hermesii or Miyamoto. Just like the Lyme immunoblot, it uses a lot of different protein antigens. You can see from the picture of the different ones that are used. And look for Miyamoto, GLPQ, they use one. Here, there's 4 of that alone. The result is increased sensitivity, increased specificity, much less likely to cross-react with viruses, non-Borrelia bacteria, and the autoantigens. And because it's species specific, you're not going to have it cross over with Lyme Borrelia. And again, you can get IgM and IgG. This is just an example. When you do a series of patients, I found Hermesii, Miyamoto, Turicate, the Turcica-like species, and they found others that were not speciated. Now, what happens with that? What does that mean? When you have a result that's positive, but the species could not be identified, that's still a positive result. The reason why they can't identify species usually is one of 2 things. Most commonly, it's because there's more than one species present, and you get a lot of different bands show up, and it's kind of hard to sort out which is which. So rather than guess, they just say, no, it's positive. We just can't tell you precisely which species it is. On the other hand, it could be picking up, and might be picking up, other species that are not, tabulated yet for North America. I mean, this is how this whole thing came about. So a positive test, again, because it's so highly specific, is something important. Talking about specificity, this is an interesting result. This is the specificity for tick-borne relapsing fever by immunoblot. So you find, going to the bottom, specificity for IgM is 98.6%, really, really high. All right, now which are the ones that they missed? Up here, multiple sclerosis was what they're calling a false positive. Well, some clinicians think that MS might be Borrelia related. Maybe this case was, so maybe it wasn't a false positive. Going down, autoimmunity and allergy, there's one that they called false positive. Well, maybe this so-called autoimmune disease or allergic disease was in fact Borrelia related. So if that's the case, then the 98.6% specificity actually could be much higher. Sensitivity, again, in early acute samples, was found to be at least 2/3 pickup rate, 100% in the second. And these are patients who are all PCR positive, okay? So it's not, some vague, well, maybe this is comparing to somebody else's test. No, these are people who are PCR positive confirmed, and then they ran the immunoblot. And so it's very, very sensitive. And again, what's not reflected here is that the positive IgM result can be seen as early as 2 weeks after infection. So again, these are game-changing results of sensitivity. So the summary is, again, information you can't get anywhere else. It's very accurate in identifying these so-called Lyme-like illnesses, the seronegative illnesses, which may be relapsing fevers and not just a Lyme disease. Again, like for the Lyme, it's very useful in early infections, able to identify many clinically relevant species, very sensitive, can't get these results from anywhere else, doesn't cross-react with the Lyme Borrelia, and being serologic, a rapid turnover. Just like for Lyme, they have a broad coverage relapsing fever assay. It's a single serology that's, again, using recombinant technology, a better test than the IFA for sure. It includes IgM and IgG, positive or negative. Doesn't give species, you need the immunoblot for that, but a rapid turnover and definitely cost effective. So here we have options. And again, the PCR, genus specific, able to detect there for many different species. It's not just a single species like the big labs. If it's positive for Miyamoto, they will identify that. They'll go ahead and do the sequencing to find it's Miyamoto, but they will show positive or negative for the others. Again, a clinical tip, during the early and acute stage of the disease is when the PCR is most sensitive, likewise immunosuppressed in the very ill late stage patients. So I want to summarize, suggested testing, I really recommend you test for both Lyme and tick-borne relapsing fever in all of your patients, because you may be having a relapsing fever patient present like Lyme, and you're going to end up with a negative serology if you don't use the right test. The immunoblot is always the first choice if you have a patient with intact immunity, because it's good for all stages of the disease, unprecedented sensitivity in early disease. And again, a late positive IgM is still significant, and now we have the proof of that by the validation studies. The broad coverage assays are just like the immunoblots, are very sensitive, very specific, extended species coverage. The cost effective and basically replaces the ELISA of the IFA. In the PCR, you'll add this onto the serologies to catch those who may not have detectable levels of free antibodies, such as very, very early in the disease, late stage disease, those who are immunocompromised. There's a reciprocal relationship between the PCR and the serology based on this immunity. So Strong immunity, high serologies, maybe not such good PCR. Poor immunity, serologies may be false negative, but you have a much better chance of picking it up by PCR. Also, thinking about that, if you have someone who's PCR positive, but has a very weak serologic response, not only is that, okay, diagnostic view, but on the other hand, it also gives you clues about their immune system. They may have some immune deficiencies they need workup. And before I close, I want to talk to you about testing panels that IGeneX offers. I think if you've gone through their requisitions, the lab requisitions, you see they offer panels. Well, they're designed specifically to make ordering very easy. It combines the most popular test into a single choice. It's also, I find, a good memory jogger. So if you're looking through, you say, oh, maybe I should test Bartonella while I'm at it. So it's a good memory jogger to go through those. But more importantly, by doing the by doing the testing panels, you can get huge discounts over ordering the tests individually. And I made some examples. This I did myself. I went through their test requisitions and priced them out and added them up. So a very popular panel is panel 1. That includes Lyme and TBRF Borrelia. So if you're looking for a Lyme-like illness, this is a kind of a screening test. Interestingly, they add the IFA to satisfy insurance requirements to those who need tier 1 and tier 2. The IFA is tier 1, IMMUNOBLOTS tier 2. Pretty clever. So that's part of it. But anyway, by going to do the panel, you save, by my calculations, over $200 of ordering the tests individually. Go to tick-borne disease panel number 6, which is basically a screening for the major pathogens and includes IFAs, IMMUNOBLOTS, PCR, fish, does the serum, the whole blood, all these different organisms, the bees and microti, and Duncani, Lyme, Tick-Borne Relapsing Fever, Bartonella, Ehrlichia, Rickettsia. This panel of individual tests saves over $1,300. Huge discounts. So let's close now. Patient symptoms are real. It's up to us, the practitioners, to help diagnose them properly. Clinical diagnosis is great until you hit the wall of the insurance companies, the doubting Thomases, and maybe the medical board. So it's really good to have lab backup for when you're making your diagnoses. You need to appreciate the many different types of pathogenic Borrelia that are here, and this appreciation is going to help us be better diagnosticians, order the right testing. And finally, the IMMUNOBLOTs have come. These are these broad spectrum tests, gives an explanation for all the seronegativity that we kind of expect and shrug our shoulders and say, well, it's a crappy test. Well, now we have a non-crappy test to use. Again, I want you to take advantage of the test panels. The money saved will allow you to include more tests for more pathogens. So it's not just a saving of money, but then say, hey, wait a minute now, I've got some extra cash here. Let me start to do some better testing. And what I emphasize all the time, tabulate your findings, share them with others. If you can't write them up, then at least post it on MMI or the ILADS email boards, because there are many unanswered questions, and the big universities are not going to answer it for us. We're the ones who are going to do it, like we have for so many years already. And this better testing is not just better for the patients, it's better for you. It makes you more secure, it makes you have a better patient relationship, maybe protected from those who are out to criticize you. And so that's it for now. I want to thank you all, not just for attending, but for all that you do. I mean, I know those who are on the call today, you're the ones who are dedicated to really good patient care, whether it be Lyme disease or any chronic illness. And I really appreciate that. I'm sure the patients do. So again, thank you very much. What we're going to do now is we're going to turn over to the Q&A. Dr. Shah will be joining us, and hopefully she can answer the more technical questions that I really can't. So stand by, and thank you.
We can take questions for maybe the next 10 minutes. We like to keep this to an hour, but we had a late start. So by all means, if you have any questions, you'll find a Q&A box either at the top or bottom of your screen. You can enter a question there, or even in the chat window is fine. So go ahead. I have a couple that were sent in to me earlier. One is, can a patient have TBRF and Lyme at the same time? I thought that was an interesting question.
Well, sure. In fact, one of the slides had showed that co-infections of these two different ones are not only possible, but they're being detected. And nobody knows how much sicker that patient's going to be. Nobody knows how much more difficult they're going to be needing for, in need of treatment. So it's really important to know that this is what's going on. You'd never want to have a person with two different illnesses and you ignore one. You want to know. You really want to know. Oh, you want to see my face? You're lost. Here we go. Am I here? Hey, here I am. The lighting is terrible. It looked like a beat, but anyway. All right, go ahead.
Okay, so here's a question. Will you send this recording to us? I can answer that. Yeah, so this will be posted on our website, IGeneX.com, as well as our YouTube channel, probably by the end of this week. Another question, does Medicare cover both the tests? I believe the answer to that is yes, Dr. Shaw. You might be able to address that. You might need to unmute your line just in case.
The answer is yes, Medicare does cover the test.
Okay. Okay, another question here from Carol. I was not able to get a positive COVID case because infected December 2019. Is it possible that immune complexes tied up with antibodies could prevent COVID? A positive antibody? I'm sorry, I didn't quite understand that question.
Read it again. Let's see if I can help you out.
Is it possible that immune complexes tied up with antibodies could prevent COVID? Prevent a COVID positive antibody test? I think it's grammatically not correct. I'm struggling reversing the words. That makes sense to you, Dr. B? Immune
Sure, Dr. Shaw, why
complexes?
don't you talk to them about that, because that's a very interesting topic. Yes,
Okay.
Dr. Shaw?
Okay, so basically what we have found, question one would be, when was the test done? Was it done immediately after infection or maybe 6 months later? That's going to give reflect on whether you see antibodies or not. Because what we have seen is when a patient is positive, we do find antibodies present and up to about 6 months. After that, they start disappearing. In our publication, we have shown that antibodies start disappearing in some patients fairly early. By about past 100 days, we were seeing less and less antibodies present in patients that were positive by PCR. So again, the question is, the answer is, I don't know whether complexes do form and that is why we are not seeing it, or is there a problem with the immune system and that is why we are not seeing it. It could be either or.
Okay.
I don't have an answer to that. Maybe Joe has an answer to the immune complexes.
Well, you know, immune complexes are specific to the antigen and the antibodies formed. So it's unlikely that immune complexes for Borrelia will interfere with a COVID test. However, we also know that Borrelia are immune suppressive. So it's very possible that someone with an active, Borrelia infection to the point of having immune complexes will have impaired immunity and not be able to have a positive COVID test when in fact they have COVID. So that's, a different answer. I mean, it's a different reason, but the same answer, that it's a possibility. Also, Dr. Shaw, there's a question I want you to answer. How about doing these tests on spinal fluid?
The COVID test?
No.
Oh.
Immunoblots and PCRs on spinal fluid.
That's a very good question. I think it would work based on some limited experience we have done with synovial fluid. We didn't have a problem running immunoblots with synovial fluid. I think we might have run CSF as well. We have run it and it works. So we can do immunoblots with CSF and synovial fluid is the answer.
Well, you see, that to me is very important because, as I showed you, Borrelia valaceana can be detected in some patients with, was a case report, had a positive spinal fluid for it, and they had spastic paraparesis. So again, it's a neurological strain, and it was able to be detected in spinal fluid. So that means if you're going to do an immunoblot, which can detect that species, then I think you should pick it up.
Two things for synovial, for CSF, we are finding that the PCR works fairly well as well. So a combination of PCR with immunoblot might be the choice. But with immunoblots, I have very limited data at this point, but we did see it to be positive in one patient who had neurological Lyme. The immunoblot was positive.
So there's a question about testing newborns. One of my favorite things for testing, the little ones, is urine testing, because you can do urine antigens for Lyme Borrelia as well as PCR. And in fact, in my practice, when we were following pregnant women who had Lyme, it was a routine that the babies would be tested at birth, and then usually every 6 weeks with a urine test. So it's a simple, definitely not an invasive way of following up on the babies.
Also, cord blood works quite well. We get a lot of cord blood samples, and they seem to reflect what's happening in there. We've got a lot of, positives for Babesia and all. In Lyme, it's quite a common sample that we test for newborns.
Okay.
Cord blood.
I have another question I received. Do TBRF immunoblots give false positives for Lyme?
No, they don't, because that was one of the first things we had to do, is to show that they do not cross with Lyme. We tested them with antibodies from all different species of Borrelia burgdorferi group, like 8 or 9 different antibodies that we prepare to the whole cell lysate, so that we're looking at all the antibodies. And when we did do the cross, we only had cross reaction to band 41. That was the only one we saw both ways. There was no problem otherwise. Now,
well, that's not a surprise, because band 41 is basically a spirochete band, and that's why just that one band on the blot is usually not significant.
Right, exactly. That's what we see. So, I mean, that's what we have seen, but we do know that there are patients who will have mixed infection. That we have seen with Lyme and relapsing fever. And in some cases, we have even confirmed it by by PCR and sequencing, that they had mixed infection because they cultured at different time points.
Okay. There's another question here. Does IGeneX have any plans to offer mold toxin testing? I'm not sure, Dr. Shaw, if that's in the works.
Not in the next year for sure.
Okay. And is there any Lyme culture testing available?
Not at this point in time, but maybe by next year we might be ready.